All right, so I'm now beginning recording. How do modern pumps work? That's the first thing we're going to talk about. And we're going to talk about the most common modern pump, which is an impeller pump. And I'm going to draw it, first of all, very roughly. Inside a modern pump is a disc. That disc is called an impeller. And on that disc are these little ribs called vanes that are made like little half moons. Sometimes they're light arcs, sometimes they're almost straight, but they're basically little ribs that stick out on the side of that disc. And then when you spin this disc, so the disc spins around, when you spin that disc, what happens is water gets drawn in. Actually, let me go to a different color. Let's go to green for water. I know I don't have blue. So water gets drawn in towards the center of that disc. And usually there's a housing which encloses that water so it can be directed right to the center of that disc. And then those discs spin and spin that water out the top, or actually anywhere out the side of this disc. Very often the part that goes up is out the top or out the side, but the water gets sucked into the center, and by spinning this disc and those ribs on that disc, the water gets pushed out the top. So I've got a vacuum, the water gets sucked in, so there's a vacuum that's created by this disc spinning in the center of it, and then it's got a high pressure zone on the outside of the edge, and that gives a place for the water to be pushed out up a pipe to the rest of the building. And the incredible pressures, there are incredible pressures that are created by this spinning disc. That is how basic impeller pumps work. Let me demonstrate it. Here I have a disc. Let's say I add some vanes, these little ribs that stick out on that impeller disc, and then I add a shaft. This is my cheesy shaft. This is the Sharpie. And then I spin this shaft, and that spinning action sucks in the liquid to the center of the disc and shoots it out the top or the side of the disc. That's how pumps work. But let's talk about the challenges with that. Right? You've got the pump, it needs to be enclosed, right? So I will draw the enclosure. That's my pump enclosure, right? So I can attach a pipe here, and it sucks water or any liquid into the pump, and then I attach a pipe here, and it pushes the water, and it contains the water that's pushing out of the pump. Where is the problem? Well, the problem is where the shaft goes into that pump housing and attaches to the back end of that disc. This shaft, right, spins, and the shaft has to somehow seal against the housing. That sealing is challenging. Because this is spinning, it creates a lot of friction, and it heats up, and it's got moving parts running at thousands of RPM, and that moving part of the shaft against the housing pretty much always leaks. It always leaks. And so the trick is to make it leak as little as possible. So everything that we're going to talk about seals and housing is in this realm. We want as little as possible. Let's draw my shaft in here. Right, we want as little as possible water dripping out between the shaft and the housing of your pump. That is the purpose of all of this packing and that is the purpose of the seals. And I'm using pump as an example. There are a couple other devices we're going to run into, like our hydraulic and pneumatic valves that also have seals and packing, because you got a shaft moving back and forth or a shaft spinning depending on the kind of device it is. But they all have the same challenges. They want to control the flow of something with a moving shaft, either back and forth or spinning. And to control that flow without leaks, you need to seal it properly around that shaft.